Okay, okay. Let me check the stream. Okay, home. Okay, refresh. Okay. Hello, hello, hello. Mic check, mic check. Okay, okay. Let me check the stream. Okay, home. Okay, refresh. So let's get back to again Leetcode. Okay, let's bring the question. Okay, let's pause it. Clock. Where is our clock? Okay. We set the timer. Timer to be 30 minutes. Okay. So this is the question. Okay, it have more dislike than likes. Okay. What should we do? Okay, let's start with this question. Okay. Question is get biggest three rhombus sum in a grid. Okay. You are given a m cross n integer matrix grid. A rhombus sum is the sum of the element that form the border of a regular rhombus shape in grid. What the hell is that mean? A rhombus sum is the sum of elements that form the border of a regular rhombus shape in grid. Okay. The rhombus must have a shape of a square rotated 45 degrees with each corner centered in grid cell. Below is the image of four valid rhombus shapes with the corresponding colored cell that should be included in rhombus sum. Okay, so if this green is the rhombus and the sum will be whatever the green elements is, right? Another will be this, so it will be sum of this. Okay, so whatever border it touches. Okay, and this is the second single one. Note that a rhombus has an area of 0, which is depicted by the purple rhombus in the bottom right corner. Okay, so this rhombus have a 0, so I can add this also. Return the three biggest distinct rhombus sum in the grid in descending order. If they are less than three distinct values, return all of them. Okay, so I have to return three distinct rhombus sum in descending order. Okay, what should I do? For the three distinct integers, what I can do is, well, there can be multiple answer, right? Because if I choose this rhombus, this has a sum of 4, 10, 20, right? I can choose what? I can choose some three distinct elements, and if they are not then three distinct elements, then what should I do? Okay, it should be a rhombus. That is interesting. And it should be in descending order. So first one is greater than second one, then third one. 2980. Okay, this one has 777. Right? So it has only one distinct value. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the value can be 987 also. Okay, m cross n is 50. Okay, it's very less. In my opinion, what I will do is, okay, this may be different because I am looking for a tilted rhombus, right? This one, this one, this one, this one. Okay, let's say it is a 4. If let's say, okay, what I can do is for every point here, let's say suppose this is a point. Now let's say this is a rhombus of length how many? 1, 2, 3, 4. Okay, let's say 1, 2, 3, 4. So 4. So what I will do is I will go on this side, go on this side, then from this side I will go on this side, and I calculate the sum. It is a hectic, but it's very hectic. Okay, wait a second. It is very hectic. Okay, very hectic. Mm, there should be some easy solution for this. How can I do it? It's very unique question. Hmm. Either what I can do is I can gather all the single, right, single unit, but it will not pass all the test cases, in my opinion. Uh, let's see. Mm, What I can do is there may be a case where uh, there are not more than sorry, yeah, there are not more than there are less than three distinct elements, but while let's say a n matrix of n matrix of let's say all elements are three, right? Then in that case, my answer returns one, but it should not return one. It should return the sum, right? Hmm. Wait a second. One thing I notice is that they are saying that the biggest three distinct rhombus sum. Okay, biggest and three distinct. Only three. They are asking for only three and the biggest. Okay, in descending order. So they are asking for biggest and they are asking for the distinct. So it should be distinct. What can I do? Hmm. Mm, can be the solution for this. Let's say, what I can do is either I can create or not. Mm, what may be the possible solution for this? Let's say, mm, I don't know. Mm, Okay, so what I can do is so they are asking for maximum, right? If there are how many elements? Okay, so every is positive, right? And there can be overlap. Yes. So, in my opinion, what I will do is I will first of all find the maximum rhombus sum, right? Maximum rhombus sum will be look like this of the dimension, but I will choose the middle one and go on till right this point, and this point. This will be the maximum. Okay. Minimum will be then I will choose the length. Okay, okay. So what I'm doing is I'm iterating on the matrix. I'm iterating over the matrix, and then one on one, what I'm doing is I'm for every so let's say for every length, I'm finding out, right? Suppose this is the length of how much? 1, 2, 3, 4. So from this will not start from this will not start from this. 1, 2, 3, 4. No, it goes out of, let's say from this. So 1, 2, 3, 4, 1, 2, 3, 4, 4, 1, 2, 3, 4. But let's suppose from here, 1, 2, 3, 4. Let's marker extension. Hmm. Let add this. Okay, okay, I know how to do this. Okay, okay, okay. Let's say I am here. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, and one. Wait. One, sorry, 1, 2, 3, 4. One, sorry, 1, 2, 3, 4. 1, 2, 3, 4. No, 1, 2, 3. Okay, so this one is the one, right? Okay. Then I will look from here. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. Okay. So this one is different. Then for this, I will look from 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so this goes out of the one. Okay, so for this, only two possible are there. So, mm, can I do this? Yes. So what I'm doing is, first of all, I need to find the maximum, let's say, rhombus size, maximum rhombus side size, right? And then I will go on till it becomes zero, or I can say till I get the three distinct maximum, right? Okay. So what? First of all, I need to find out what is the maximum size. What is the maximum rhombus side size? What can be the maximum? Uh, it will be. So let's say it is n cross m, right? Sorry, n cross n. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 3, 4, 5, 6, 7, 8. Okay. And 1, 2, 5, 6, 7, 8. Okay. So, so for this, can there be, uh, let me erase it. Mm, okay. Uh, let's start from here. So 1, 2, 3, 4, 1. Okay, so how many? Okay, but 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so it is going out of the box. Okay, so for 8 cross 8, the maximum is what? 4, right? It is going out of the box. 3, 4. Because if I choose 5 cross 5, right? If I choose 5 cross 5, then I know the this part will be how much? This will be 9, right? Because for 4 cross 4, it should be how much? It should be 7. So 1, 2, 3, 4, 5, 6, 7. Yes, it is 1 less than the double, right? Because this part is coming uh, only once. Okay. So if my dimension is m cross n, right? First of all, I need to choose this also. So 1, 2, 3, 4, 5, 6, 7. Okay. So what I will do is I will first of all find the maximum of this, not maximum, minimum, and minimum. What should be the solution? Should be the solution. Uh, what is the maximum, right? Maximum. What is the maximum? So if it is m cross n, then it will be minimum of whatever m and n is, right? Let's suppose minimum is this. Okay, so it is. Let's say this part is not there. So it is 8 cross 7. So minimum is 7. So I know this can go till maximum 7, right? So whatever that is, so it divided by 2. 2 4 ja, okay, and just take a series of that, I suppose. Hmm. Let's see. So here it is 1, 2, 3, 4, 5, 2, 3, 4, 5. So it is 5 cross 5. So if it is 5 cross 5, so if it is 5 cross 5, then minimum is 5 cross 5. So it will be maximum possible will be what? Uh, maximum possible will be what? So minimum is 5. So 5 divided by 2, and I will take a seal. So it will be 2.5. So it will be 3. So maximum possible is 3. So let's say from here it is not possible. From here it is possible. 1, 2, 3, 1, 2, 3, 1, 2, 3, 3. Okay, as you can see. From here onward, 1, 2, 3, 1, 2, 3, 2, 3. Okay, so from here it is not possible. Okay, so I got the maximum. So I will then decrement. Hmm. Okay, so what I will do is time is very less. Okay, so maximum length of what will be minimum of, let's take the dimension. M will be grid dot size, will be grid dot size. Okay, and will be grid of 0 dot size. Okay, so minimum of m cross n whatever divided by 2, and I will take a seal value. Okay, okay. Now what I need to do is while maximum len minus minus, while it is greater than 0, right? What I should do now, I need to iterate on every index, right? So for integer I equals to 0, I less than what m I plus plus, for integer j equals to 0, j less than n, j plus plus. So now what I will do is I will start from every point, from here, from here, from here, and then what I will do is I will take 2 loops. So sorry, 4 loops. One from here to here, one from here to here, and then from here till here, here till here. So for every this, I will take 4 loops. It will be in queue. Let's say, let's think about it. Okay, okay, fine, fine. So what I will do is, first of all, I will go on like, so if I and j, so I'm going from bottom right, so it will be I plus 1 and j plus 1, right? I plus 1, j plus 1 is towards right. What about left side? So it will be I plus 1 and j minus 1. So I plus 1, j minus 1, right? And let's say bool flag, or let's say is possible. Uh, is this what is this number possible for not from this I here, right? So what I will do is possible true. So what I will do is, first of all, from this point I will go on till right, till the moment I till the moment the number of boxes I touch is equal to the maximum. So the boxes I need to touch is, let's say in box is to 0. Okay, while I is greater than 0. Okay, I should be greater than 0, and sorry, I is getting increment, right? So I should be less than m, and not I. Let's say temp. Okay, I need a temporary variable. So integer temp I will be I and integer temp j would, let's say j. Okay, while I is less than m and what while I is less than m and j is greater than 0, not j, yes, j should be greater than or equal to 0. What I will do is I have not, so it will be temp j, and this should be temp I. Yes, what I will do is I will box and box. First of all, I'll check whether it is possible or not. Then I will check, and box is not equals to the maximum length I am looking for. Okay, the moment it equals maximum length, then I will get out of this. The box is box maximum. So temp I will be whatever. Temp I will be temp of I plus 1, right? So if I am is this of temp I, then temp of I will be here, and I'm looking for going for this column, right? So temp of I plus 1 and j minus 1. So this will be there, and temp of j will be temp of j minus 1. Okay, and I will increment the box saying that okay, I included this box, now I am this box. Okay, so again it will go on this box, so it will be how much? Let's say box is 1 because I am starting from this, right? So box is 1, so here box is 1, so it goes here. Now here it is box 2. Okay, now here it says box 3, right? Yes. Okay, okay. So if box is not equals to maximum length, okay, maximum length, then I will say okay, is box equals to false, because this is not possible. Okay, for this. Okay, and if it is possible, then what I will do is okay, suppose I am reached. Now I need to go on in right direction. So again I will set that, reset the temp I. Temp I will be what? I, and temp j will be j. Okay, again while, so temp I should be less than n, and temp of j should be less than n, because now I am going in right side. Well, there may be a j where this column gets empty. So and let's just reset the box. Box equals to 0, and box, while box is not 0, let's say 1. Okay, box is not equals to maximum n. Okay, so here also what I will do is I will temp of I will be temp of I plus 1. Okay, and temp of j, this time it will be incremented, temp of j plus 1, because I am going in right side. Okay, and I will increment box, and if again box is not equals to maximum n, what I will do, I will say is possible, this is false, right? It is not possible. So okay, let's say I reached here, what I need to do is I need to store this index, right? This index and this index. Suppose from here I reach here, from this here, this, because now I need to write a loop to go to here to here, and from here to here. So let's say left I is equals to this temp I. Okay, before updating, and integer left j is temp of j. Okay, and here integer right I is this temp of I, and integer right j is this temp of j. So this left I left j is this, because from this here, and this is this, right? From this I'm going from this. Now from this left I left j I will go on till here, and from this I right j I'm going till here, right? Right now I'm not calculating sum. Okay, wait for I will calculate it. So now I need to write a loop. So while, so again what I will do is I will initialize box as well. Okay, so while I'm I'm going on right side. So while left of I, let's make it, while left of I is less than m, and left of j is less than n, and box is not equals to maximum length. Okay, maximum length. What I will do is I will first of all left of I will be upgraded. Left of I will be left of I plus one. Let's say let's just do this much. And what about left of j? Left of j will be also incremented, and box will be also incremented. Okay, and if box is not equals to maximum length, then this is not possible. False. Okay, and again what I will do is again I will initialize box as well, and while right of I is greater than 0, not sorry, right of I should be less than n, and right of j should be greater than 0, right? Because I'm going left side. So greater than equal to 0, and box is not equals to maximum length. Okay, I will first of all right of I will get incremented, right of j will get decremented, and box will get incremented, right? Okay, and what I will do is if box is not equals to maximum length, then is box is equals to false, right? Okay, finally it is done. Now, okay, so and last what I will do is for the next iteration I will decrement it maximum length minus 1. Okay, now what I need to do is I need to calculate a sum. So for this, let's say the sum is what? This sum equals to 0. Right? Now what I'm doing is let's say um, let's say for this I'm adding this sum will be equals to whatever the matrix we have grade of ij, right? Now this one is what is doing after updating. Or let's add it here, right? Sum plus equals to temp of I, uh, grade of temp of I and temp of j. Okay, grade temp of I, temp of j, right? Mm, so this will get add, then temp of I will this here, this will get add, this will get add. Okay, and let's add it here also. Sum plus equals to temp grade of temp of I, temp of j. Okay, okay, I know this will get add 2 times. So what I will do is after this I will subtract this one by I will subtract this by 1 time. Okay. Okay. Now what I will do is uh, 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 now okay, okay, mouse is done. Okay. Now what I will do is this is also get added. So let me remove it so that it can be added from here. So box, not box, should be some. So let me remove it one. Some minus equals to grid of left of I, left of j. Okay. Okay, and what I will do is I will add the sum here, left of grid of left of I, left of I, left of j. Okay, and what I will do is again I will remove it here, sum minus equals to grid of right of I, right of j. Okay, right of j. Then I will add the sum here, sum plus equals to grid of right of I and right of j. Okay. One thing also that this will also get added two times, right? So what I will do is, let's say ij is here and the maximum length is what? 3, right? So sorry, 1, 2, 3. So it will be 1, 2, 3, 4, 5. So after this, if everything is possible, so I will remove this sum by 1. So it will be grid of whatever I plus whatever the length is, maximum length by 2, right? It will be by 2. So let's say 1, 2, 3, 4, 5. So it will be 6, will be maximum length minus 1. So if it is 6, then j. Okay, now the sum is good. So what I will do is let's say I created a vector of integer v. Okay, and I push the sum here. If everything is good, we will push. Okay, time is over. Let me just push this left. We dot push back this sum. Okay, fine. So what I will do is false equals to false. Instead of this, what I can do is I will say just continue, right? Continue from this side. Let's copy this. And continue. Okay, continue from this side also. Okay. Now after this, what will happen is in my v vector, all the possible sum will be there. So what I will do, I will sort this. So sort v dot begin, comma v dot end, and I will create a vector resultant. Okay. So while for integer, what I will do is, let's say I is equals to integer. I I will be v dot size minus 1. Yeah, I need distinct value, right? God, instead of storing in I should store it in set integer st, because we need distinct value. So let's say st dot insert, right? So what I have to do, I don't need to do this. Okay. So while now I will iterate in reverse. So for auto iterator equals to st dot reverse begin. Okay. It is not equals to st dot reverse end, and sorry, and it minus minus or plus plus. Say let's delete count equals to 1. Okay. So rest dot push back this star of it, right? And count will be, if any moment count becomes 3, 3 or 4. Okay. Let's see. Count is 1. Okay. So 1 will get 2, 2, 2, 2, 2. Okay, it will be 4. So in the end, I will return what this resultant. My God, what is this code? And it is giving me runtime error. My God, not doing this. Where it is giving runtime error? Here or where? It is giving me here I less than m j plus plus. Okay, wait, what is out? Temp of I. Okay, temp of j. Okay, this was equals to. We don't need this. Was equals to 1. While temp of I is less than m, na? Rows is m. Okay, and temp of j is greater than 0, and box is not equals to maximum null. What I am doing is I am adding the temp of I, temp of j. So temp of I, let's say temp of I this I plus 1 will be this and j minus 1 will be this. Okay, so this is okay. This is valid right here. This box is not equal to temp. Okay, so left of I, temp of I. I think okay, okay. Let's see here. So here box is equals to 1. Okay, it will get added, then it will get here. So here box will become 2. Okay, okay, right? Yes. Now in this call, box is not equals to box is equals to. So this is not getting it. So what I will do is box is not equals to maximum line is 3. Box is here is 3, but it's not getting it. So let's say box is box price. Box or let's say box is 0, right? Let's say box initialize with 0, 0, 0, 0. Okay, let's see. Oh my god, I'm not doing this. Okay, he said this. Okay, next question. Very bad question. I don't know. What the hell? Okay, what is this? Let's start finding pairs with a certain sum. Okay, you are given two integer array nums1 and nums2. Okay, so we have given two integers array nums1 and nums2. You are tasked to implement a data structure that supports queries of two types. Okay, add a positive integer to an element of the given index in the array nums2. But you are tasked to implement a data structure that supports query of two types. Add a positive integer to an element of a given index in the nums2. Okay, count the number of pairs ij such that nums of I plus nums of 2j equals a given value equals a given value where I is okay. Hmm. Implement the find some pairs. Okay. Okay. So number of pairs such that they equals this, right? And I have to find the count of pairs. Okay. Index nums1 nums2. I think this okay, nums1 is okay. Nums2 length is greater, right? Nums1 length is fine, but nums2 length is greater. This is interesting. Nums1 of I. Okay, okay. At most 1000 calls will be add count. Okay. So what I think is okay. Nums1 we have to add. So add. What I have to add is in which array I have to add. Add a positive to nums2. Okay. So in nums2 I have to add. In nums2 there is an index and I have to add this value to that index. Okay. And then what I have to do, I have to count the pair that sum equals to. Okay. Okay. So I'm thinking of a hash tag because see, count to calculate count, I have to iterate on every this array, right? So let's say nums1 is this and nums2 is this, right? So this can be very big. So I will not count this. I will whatever. Let's say I'm looking for this pair, right? Let's say I need to find some 7. So let's say this one is from the first pair. Then in num2 I will look at it and I will see how many index 6 is present. So that many pairs will be there, right? And this add will manipulate there. So let's say we created a hash map which will store that okay 7 is present it at index 0, 3, 5, right? Now what they are saying okay add 3 to this, add 3 to this. Sorry, what? Add whatever is present at index 3 and this value. So let's say so currently 7 is present. Okay, let's say they are saying add 3 to it. So it will become 10, right? So now this will be issue. Okay, I understood the count part. Okay, I need to find that how efficiently I can calculate the number of index for a particular pair. Right, let's say I'm looking, let's say 7 is present at index 0, 3 and 5. Now how efficiently I can remove 3 here, right? Hmm. Mm, okay, okay, I understood. Let's say, okay, fine. Let's say I want to add 2 at index 3 and at index 3 I know this is a value, there is a value 7. Okay, so what I will do is I will firstly go to hash map and I will choose whatever set there is present and I will remove index 3 because this is getting updated. And what I will do is I will add this value 7 plus 8 9 and I will check whether hash is present or not and I will insert it there. Okay. 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 Let's see. So let's create a vector integer v1 and v2. Okay, upon constructing. Uh, so v1 will become nums1 and v2 will become nums2. Okay, fine. Another thing I want to do is I want to create a hash map of set. Can I create that? Let's see, map of integer and set mp. And what I will do is I will iterate on for integer equals to 0, I less than v1 dot size plus plus what I will do is mp of whatever value there is present. This is a set, so I will insert this index I. Why I am creating a set? Because I want to remove it, right? I want to remove in O of 1. Sorry, not O of 1, in login maybe. Okay. Similarly, for integer I equals to 0, I less than v2 dot size plus plus mp. Wait a second. Okay. Oh, sorry. Uh, this should be on v of 2, right? Because add operation will be in v2. So v2, okay, fine, fine. Okay, I inserted it. Now, what I will do is here, first of all, I get the value which I am updating. So it will be v2 of this index. Okay. Now what I will do is I will remove this index from this value. So mp of val will be a set. Erase this index, right? So I erase this index from that set, right? Okay. And now what I am doing, I am adding this value. Sorry, well, let's say value plus equals to value. Now value is updated. Now what I will do is I will I will here insert this index. And now whenever this is operation, so integer, let's say c equals to 0. Now for integer I equals to 0, I less than v1 dot size, okay, I plus plus. Let's say the first value is this. So value I'm looking for is what? So value I'm looking for is let's say the current value is 1. Is tot going to be positive? Okay, tot is going to be positive. Tot going to be positive, right? So let's say this is 1. No, let's say this is 2 and I'm looking for 8. So I'm looking for 6. Let's say this is 7 and I'm looking for 3. Then it is not possible, right? So let's say value will be tot minus this v of I, right? Tot minus v1 of I, and c will be incremented by how many indexes in nums2 this have. So np of this value. And in the end, I will simply return the c value. Let's see. What happened? What happened? C plus equals to MP value. Okay, so this is okay. This is a set, right? So dot size. How many index are there in nums2 which has a value? Well, wait, what? It is giving me wrong answer. It is giving wrong answer. My size is wrong. Why? So I erase the index. Let me try it. Okay. So V1 has 1, 1, 2, 2, 2, 3. Okay. V2 has 1, 4, 5, 2, 5, 4. Okay. So they are saying add this value. Okay. Okay. Count 7. Wait, what? Find where? Okay. These two are met. They are saying count 7. Okay. 7. Okay. So 4, sorry, 0, 1, 2, 3, 4, 5. Okay. So one value is present in only one index. Two value is present only at one index. Three is not there. Four value is present at two index, 1 and 5. Five value is also present at two index, 2 and 4, right? Okay. So they are saying count total of 7. Okay. So for 7, I will iterate on the first area. So 1 is there. So I'm looking for 6. 6 is not present. Again 1 is there. 6 is not present. Again 2. So for 2, I'm looking for 4. So there are two, what? So there are two pairs, right? So for this, there are two pairs. So 2 is there. Now for this is also 2. So 2 to 4. For this is also 2, 2 to 4, 5, 6. Let's say for this 3, 2 to 4, 5, 6. And now for this thing, I'm looking for 7. So I'm looking for 4. So again 2. Wait, what? No, 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 no. Okay, this should be 5, right? Okay, 5. Oh, sorry. Okay, so it is 5. Now this is fine. So now they are saying that add at index 3 this 2. Index is 0 based. So at index 3 add this value at index 3. So add this, insert this value. So what I'm doing is value will be v2 of index. Value is here, the value is 2. Okay, 2 is present in index. So oh sorry, it will be not val, it will be value. Okay, so from this I'm erasing value. Okay. Now it will be fine, I think. Okay, now it is fine. Uh, in my opinion, the time complexity would be, so for this, it is what, 1000 login, because I'm accessing this. For this, it will be login, because I'm erasing and I'm inserting, right? Let's submit it. It is giving me wrong answer. But no, 000. My output is 000. But no, no, what is wrong? What are they saying? Add a positive integer to an element of a given index in the array, and it will be on num storage. So value v2 of index. Okay. 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 Sorry. So okay. Sorry. See, I'm not updating in v2, right? I have to update in v2 also. So v2 of this index, this will become this value. Okay, I understood. Right, I am not updating on v2. That's why it is giving a wrong answer. Yes. Okay, let's submit it now. Okay. Okay, the time complexity is very bad. Only 5%. The time complexity, what will be the time complexity? It says at most 1000 call are made to add and count each. With 1000 call, right? So 1000 into whatever the time complexity is this. So this will be, I'm again into 1000 and I'm accessing a value. So it will be log n. So it will be n square log n. For this also, this is only log n, right? So I'm accessing, this will be O of n. Okay, I'm inserting, this will be O of log n. Okay, let's move to the next question. Jumping 7. Okay, let reset. Let me check the stream. Stream is going. It's only login, right? So I'm accessing. This will be O of n. Okay, I'm inserting. This will be O of login. Okay, let's move to the next question. Jumping 7. Okay, let reset. Let me check the. Okay, I'm inserting. This will be O of login. Okay, let's. Okay. Okay, let's start the timer. Uh, okay, jump game 7. This is 5, 6, 7. Okay, so you are given a zero index binary string s in two integer min jump and max jump. Okay, in the beginning you are standing at index 0, which is equal to 0. You can move from index I to index j if the following condition are fulfilled. Uh, you are uh, you are given a zero index. Okay. I am given a binary string and two integers min jump and max jump. Okay, in the beginning you are starting at index 0. Okay, fine. You can move from index I to index j in the following condition are fulfilled. So they are saying that okay, I can move from index I to index j if this condition is followed. Okay, so if I plus if j is greater than from min jump and minimum of I plus max jump or the length. Okay, So for current I, there will be a range, and wherever I am jumping, it should be a zero. Hmm, that is interesting. So let's take the first. Let's take the first. Let's take, so it is 0, 1, 1, 0, 1, 0. So I am here. So they are saying minimum jump of 2. So minimum jump of 2 means for this particular I can jump from, the range will be I plus minimum. So 0 plus 2. Okay, from this. So this is the indexing 0, 1, 2, 3, 4, and 5. So from 2, I can join from 3. So it will be I plus max. So, okay. For this I have these two values, and the SJ should be 0. The SJ should be 0. So in this range, only this 0 is present, right? So I will move here, right? I will move here. Okay. Let's say I reached here. Now for this again, the range will be from here till the maximum. Sorry, here. Okay. So there is only one range and it is 0. So I will jump. So what I did was I took a jump from here till here. So one jump, and I took a jump from here till here and second jump. Okay. So they are saying that return true if you can reach, or false otherwise. Okay. So I know a base case, not a base case, but let's say what is, okay. If the last, because they are saying that if the last position is not 0, then it is always false. Okay. Then it can be false. Okay. So for a particular index, I have given a range. Okay. Okay. For a particular index, I have given a range. Okay. Okay. So I understood. So there will be a case where here, this is 0. Right? Let's say there are some 1 here, and from here there are, let's say, a 0 here, a 0 here, a 1 here, a 1 here, a 0 here. Let's say I jump from here, right? Let's say I jump from here to here, and let's say this is the range. For this is the range. Then it, if I jumped here, then it says not possible. But that is not right, sir. Right? I can jump here, right? And then I can jump here. But if I jumped here, then there may be a case where I'm ignoring the solution. Hmm. Yes, okay, okay. Let me do it something. Okay, so the length of this SSI is either 0 or 1. Okay, okay. So they are not saying for the minimum jumps or something like that. They are saying that just return whether it is possible or not. Right? Just say whether it is possible or not. Okay. And one thing important here is that I am always reaching on index. Sorry, I'm always jumping on an index where the character is 0, right? So that's it. Uh, what I can do is, let's say for every index 0, I determine whether I can jump from here or not. Is that possible? Is that possible or not? What I'm saying is for every, is that possible or not? Okay. 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 Mm, um, let's say from I get a range. Okay. I get a range of, let's say L and R, right? Uh, let's say for a particular I get a range of L to R's, right? From here till here, I can go. And there will be, let's say, 0 here, let's say 0 here, let's say some 1 here, let's say some 0 here. So what I will do is, what I will do is, right, okay, L till R. So I will, for particular I, now I will iterate on this L to R. And what I will do is, mm, what can I do? Okay, let L to R, and if in L to R, what I will do is I will mark them as positive. Let's say true, 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 that I can reach here, right? Now for this 0, I will again start marking, okay, okay. In this way, I can write the solution in n square, but they are asking me for big of n solution, right? So there may be some duplicates. Okay, let's reverse it, right? Let's start from the end. Let's start from the end. From end, I will get this much. I will get a range. Let's say 0, 0, 0, some here. Okay. No, I don't think so. I think I need to go from this position to this position. 0. Let's see this example. 0, 1, 1, 0, 1, 1, 1, 0. Okay. So for this okay, let's color it back. So it is not back. Let's say this is 0, 1, 2, 3, 4, 5, 6, and 7. Okay. Okay. Now I is here. Now for this particular I, the maximum is 0, 2, 2, 3. So this is the range. So there is only one possible. So I will be now here. Now for this will be the range. Sorry, this will be the range, and there is no 0 present. Okay, okay, okay. Maybe I understood. What I need to do is, what I need to do is, for let's say for whatever 0 I'm getting, let's say for whatever 0 I'm getting, if in a way I can calculate whether the value in it is range, are there any 0 present or not? Are there any 0 present or not, right? Uh, are there any 0 present or not? For this, there are no 0 present in this, right? And it is not the end, right? It is not the end. Yes. Then my answer should be false, right? So what I'm saying is, let's say this example, 0, 1, 1, 0, 1, 0, right? For this, let's say for this I, what the hell? For this I, uh, the range is 2 to 3, right? So for this is, so for this 0, there is a window. Sorry, there is, what? There is 0 present. Okay. So let's say for I come here, for this is the, and there it is 0 present. Okay. So it is possible. And for this, I'm reaching the last. Let's say, let's say this is 1. Okay. There may be edge case. Edge case will be look like this, right? So let's say 0, 0, 1, 0. 1, 0, 1, 1, 1, let's say 0, 1, 1, 1. That's it for this. This is the range. It is fine. For 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 there's no range. Okay. Hmm. What I'm thinking. Uh, okay. One thing I can do is why I think that solution will work. I don't know. It should work, right? If I'm at any zero, and for that there is no range possible. For previous one, there is possible. Okay. You can let me write the solution. I think that. Oh, sorry, I reset it. Okay. Let me write the solution. First of all, I need to calculate the prefix frequency of this. So let me calculate a factor of integer frequencies. Right? It will calculate the frequencies of the zero character. String length will be s dot length will be of n size. Okay. Okay. When it is I equals to 0, I less than but n I plus plus, let's say count is 0. Okay. And if s of I is what, if s of I is equals to what, what? 0, of course. If s of I is 0, then I will increment count, and the frequency of this I will be this count, right? So okay, then what I need to do is, so for integer I equals to 0, I less than, so first I need to check it if s dot last in this is not equals to 0, right? Then I will return false always. Okay. So for integer I equals to n, I less than I plus plus. So if but s of I is 0, then I need to check for the range, right? So it range will be, left will be what? F will be I plus minimum, I plus minimum, and right will be what? Minimum of I plus max jump and s dot length minus 1. Okay. So uh, number of number of 0 will be frequency of R minus, if L is greater than 0, right? Then frequencies of L minus 1, else 0, else subtract 0. Okay. And if for a particular particular 0, I get a range 0, so I will return false if it is 0. And if everything happened fine, then I will return true. Let's see. I think so. It will work, but not for every case. I think there is some issue here. They are saying I plus minimum of could not match. Okay, so this will be, let's say, n minus 1. I plus max jump. You see here it is giving me wrong answer. It is giving me false. Wait, why it is giving false? Uh, so 0, 1, 1, 0, 1, 0, right? So frequency is 1, 1, 1, 2, 2, and 3. So let's say I'm starting from here. it is 0, right? So its value will be what? Value will be I plus minimum, that is 2, and I plus minimum, that is 3. So 0, 1, 2. So this is the range, right? How many count are there? So this frequency, this is L, this is R. So frequency of R minus frequency of L minus 1. 2 minus 1 is only 1. So it is not 0. So it will work fine, right? So now I is here, I is here. Now I becomes here, right? So what is the range? This is L, this is R, right? So 3 minus 2, that is 1. So it is fine. So I will become here. L and R, okay, okay. I think it should be N minus 1, right? Wait, why it is giving false? I minimum of I plus maximum and minus 1 number of 0. If it is equal to 0, then I should return false, right? Frequency of R, if L is greater than equal to 0, then frequency of L minus 1, else it should be 0. Let's say see out number of 0. But only 0. Wait, what what's going on? There are more than 0 here, right? St dot I. Let's say I. What is happening? 0, 0 dash. Wait, what? Is it frequency is wrong? Count is equals to 0, and if S of I is equals to this character, it is 0, right? Count plus plus, and frequency of I will be count. S of n minus 1, I think it is fine. For frequency of I. Let's see the frequency array. So 1, 1, 2, 2, 3. So 1, 1, 1, 2, 2, 3. Okay, it is fine. So I am iterating for integer I equals to 0. If S of I is equals to 0, okay, so S of I is equals to 0, okay. L will be I plus min jump. Min jump here is 2, okay. So 0, 1, 1, 0, 1, 0. Okay, indexing is 0, 1, 2, 3, 4, 5, right? Right. I is here. So, okay. So L will be I plus min jump. So 0 plus min jump will be this L. R will be minimum of I plus max jump. I plus max jump is 0 plus 3 or 5. So it will be R will be here, right? So number of 0 is frequencies of R. From here R it was 2. So 2 minus, is L greater than 0? Yes. Frequency of L minus 1. That is this. Wait, why it is giving me the hell? What frequency of L, frequency of R, and forward I. Oh no, I don't need to submit it. Uh, 0, 1, 2. 0, 1 and 2. Frequency of L is okay. So 2 minus 1 is what? I think there is this is the problem, right? It's removable. Number of 0 will be whatever frequency, and if L is greater than 0, then number of 0 will be minus equals to frequency of L minus 1. Now it is becoming good. I don't know what was the issue. Let's run it. Still, I think there will be an issue. Let's submit it. Mm, yeah, I knew. Wait, it is giving me false. Wait, what? It should be true, right? Okay, okay. Oh, sorry. Like for this 0. Okay, for this 0. Yes, that what I was thinking. For this 0, the range is not there, right? So the value will be 0. For this 0, 2. 2 will be this. Hmm. Okay, okay. What should I do? Main jump is 2, max jump is 5. Hmm. Let's say if any moment L to R, right? If R is equals to n minus 1, then I should always return 2, right? Because why I need to go again and again? Think so. Still, this issue. Main jump is 3, okay. Say for this, output is true, expected is false. So let's say for this 3 or 0, 0, 1, 2, 3, 4, 5. I can reach here, right? I can reach here, okay. For this 0, 0, 1, 2, 3, okay, 3, 4, 5, okay. Okay, I can reach here. Now for this 0, 0, 1, 2, 3, okay. Oh, sorry. If L is less than R and N, or let's say equal, because in this case the L becomes greater, right? Now let's submit. Still it is giving me wrong answer. Jump is to okay. Let me think something different. I'm still giving the wrong answer. Okay, something different. What different should I think of? Mm, mm, okay, okay. Okay. So what I did was for every zero I calculated whether this zero is possible or not. Sorry. Right. Since I need to get to the last in jump is 2, okay, this is possible, for this is possible. Let's say for this 0, 1, 2, okay, it can reach here, so it is giving false. Why false? I think let's say for this, let, let's write for this 0, 0, 1, 2, okay, 3. No, let's say for this 0, 1, 2, and 3. Wait, for this maybe 0, 1, 2, and 3. Yes. Yes, yes. For this zero, it is giving the wrong answer. Hmm. Oh, something else. I think of. Hmm. Maybe if there is a way that I am at particular index I, and I can determine whether there is a way from left onward that I can reach from here, right? How can I determine it? I mean, I can determine it by, let's say, I get a range that is still R, right? Right. I can check whether is there any I belongs to this or not. Mm, no, no, time is over. Okay, I don't know about this. What should I do? Can reach. It's passing some cases, but okay. What should I do? Uh, Okay, let me do this question. Okay, so what I'm doing is what I'm doing is what I want to determine whether I can reach the last index or not. For reaching the last index, I should get a range, right? Okay, let's say from last onward, okay, from last onward, I know, okay, I said this zero. So for this zero to be happening, what I need to do is I need to find a zero such that the j of that will be this, right? I need to find a zero such that the j of that, sorry, the r of that will be this last index. Okay, we have found that. Now there may be multiple zero. Right from here onwards, for this is not possible. this j is possible. So then what? Okay, 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 okay. Uh, I need to do what to do, what to do, what to do. Think, think. Hmm. Let's take this as an example 0, 1, 0, 0, 0, 1, 1. Okay, here, but minimum is 2 and 3, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 10. So let's say 0. Okay, this is the range, right? So I here. So 0, 1, 2, 3. So this becomes the range 0, 1, 2, and 3. Okay, this becomes the range 0, 1, 2, and 3. This becomes the range 0, 1, 2, and 3. This becomes the range. Okay. I think now I got the solution. Maybe let's see. Now I don't need the frequency. What I will do is for initial I will calculate the L and R. L will be what? Min jump, and R will be maximum, right? R will be maximum. S of 0 is always 0, right? What I will do is, let's say, what integer I will be L, and while I is less than equals to R, right? While I is less than equals to R, okay? What I will do is now if I, sorry, if S of I is is not equals to 0, then what I will do is I will simply I plus plus and continue, right? I will continue. As if I is I plus plus, so R will be now, R will be what? R will be for this I, it will be minimum of I plus maximum, right? I minimum of I plus maximum and n minus 1, right? If at any moment if I is equals to n minus 1, I will return true, I will return false. Let's see this one, whether it is true or not. I don't think it is true, but I believe it is true. Time limit exceeded. Wait, oh, sorry, I am not incrementing I here, right? I should also increment I. Mm, Case 4, it is giving wrong answer. R value minimum of this I, 3 and 5. So for this, 0, sorry, 1, 2, 3, 5. So this is the range, right? Mm. 0, 1, 2, 3, 4, 5. I reached here. What is the range? R is this, but my eye will also change. Okay, let me put different day. Okay, let's end the stream.